Hello sir, my name is Usman. Let I show you your simulation. So first, I already give a link of your motor driver, so you can check out all information about your driver, uh, its voltage limitation and everything here. So we are using 5 volt for logic voltage, and you can use any number of voltage for your motors. Make sure you set current of your current limit of your motor. So here is our driver. I think there is 3.1. so in motor A you directly connect serial 2 pins, RX pin of ESP32 connect with the TX pin, and RX pin TX pin of the ESP32 connect with the RX pin in your driver. Okay, so you can also read out everything in here about your motor. In motor B, I was used step and dir pins, so you can set step and dir pins in motor B for controlling. And one important thing, you must be set current limit, so you can set current limit through this VREF pin plus connect with the potentiometer. I think okay, here is it. You control through this potentiometer to VREF and set current according to your motor current limit. Here is its formula. Okay, so if you don't know how to do this, I will be set according to your motor, so I will help you if you need to set the current limit. Anyway, this is the information about your driver. So I have already give you a simulation pin layout. So this one is your pin layout, so make sure you must be use if I use pin number is 1 and 3, that's mean GPIO pin number 1 and 3, this one 1 and 3, so on. So this is a standard numbering to pin out, not this one. So make sure you connect exact pin like GPIO 1, 3 and 23, 22 and so on. So you also give 5 volt plus ground, this ground, and 5 volt to TMC2209. so don't give a voltage of 3 volt, you can give a 5 volt. Vin actually used for input and also for output logic level. Okay, so this is your ESP pin layouts. You can directly set your pins according to your ESP32 and match with the code. So here is for motor 1, 1 and 3 pin because serial communication we are. One last thing, you must enable this pin. Here is it. This pin directly connect with the ground, or you can connect with this pin. Okay, so and when it's at logic level low, then our driver is active. So make sure enable pin is connected with the ground. And okay, so here is code I set for this driver according to your needs. Next, you set all these pins according to your ESP32 GPIOs. Okay, make sure your pins are connected correctly. Then you can set the speed. I set the speed limit 100 to 1000 for motor A. You can set any number from 100 to 2000 or any more. You increment any number at one press of button. Okay, so one last thing, here I set for motor step 2 steps. So when you press a button, either left or right, motor B will go a steps of 100, or you can set 1 to 200 and so on. You can also set the micro stepping enable. So actually I'm not using a micro stepping. If you need a micro stepping, I set a micro stepping here. So if you need to increase I use a 16 micro stepping. You can use 256 or 1 or any number. You can set here micro stepping. Okay, so I enable any cool stepping, and also have a strong brake stall. So this is a code about your driver. So next thing is I'm use simulation. So because in simulation there is no same driver available, TMC2209. So I use A4988, but scenario is exactly same and code is almost same, but I was using library stepper.cpp. So here is a 4 button, these 2 buttons for increase and decrease motor A speed, and these 2 buttons when you press left or right, it go left and right of motor B until a limit switch reach. So this is your exact scenario that you want. Okay, so I have already connected these pins, but this is not related to your driver, it's related to A4988, but scenario is almost same, and I also use almost same pins. So because in A4 they have no serial communication, so that's why I need deal and step pins. And also these motors are not same to your motors, and no limit switch are available, so that's why I use push button as a limit switch. Let's we check the simulation. Okay, simulation start, and motor A according to our scenario is running in left to right direction. So when limit at reach, it reverse their direction right to left, and when again left limit is reached, it's triggered by push button. You can directly connect your limits pin with exactly same pin, because your limit sensor exactly give a ground when it reach a limits. So I have already set the logic at active low logic, and connect with pull up resistance with them. Okay, so here is motor, when it reach left or right, it definitely change their rotation or change their direction. So you can also increase the speed. This one is a 50, and you can this one is 50 and 100 and so on. So you can change the speed of motor. So last one is our motor B. Motor B can go, but we set also here limit switch. So when limit switch is pressed, motor A will not move, because we already reach at limit. So you can move any direction until it reach. When it reach, it will be stopped. So here its step are you can more smoother or put micro stepping, or you can also use increase and decrease the number of steps in motor B that you want to move when you one time press. So this scenario is exactly working that you require, but I use this library for, because this driver. So you in your code I use exactly same library that you have driver. Okay, so I hope it's